When Stephen Hawking said, if you feel there is a black hole, do not give up because there must be a way out. And we could not agree more. Also, if you abide by the same, you have come to the right place. So hello and welcome. This is Himanshi Kaushik, your host of the day, and I would like to welcome you all in today's webinar on black hole formation. And I hope that you all are safe, sound, and happy at wherever you're taking this webinar from. So before we know a lot more about the science, black hole, and atmosphere, we have our expert with us today. So I shall introduce you to our expert. We have Dr. Shankar Pathak sir, an assistant professor, School of Chemical Engineering and Physical Sciences here with us. He is a magnetic personality who works in the field of theoretical cosmology and astrophysics, gravitational waves, dark energy, dark matter, black hole, and loop quantum gravity. He has completed his PhD from Institute of Theoretical Physics, Shandong University, China, and has been working in exploring the theoretical as well as phenomenal aspects of real scalar fields of cosmology. He has several research papers under his reputed journals and has supervised many UG, PG, and PhD graduates as well. So his area of expertise is very dynamic, that is dynamical dark energy in universe, quantum effects on gravitational waves, and formulation of quantum field theory in curved space-time. Sir, we are very much in pleasure to be here, to be able to listen you in the webinar, and so looking forward for an amazing session.
So, thank you, Himanshi. So, I'm audible.
So yes, so you're audible, sir.
So, very good morning to all. So, black hole formations. So, shall I start?
Yes, sir, sure, sir.
Okay. So, black hole. So, it is clear from the name. So, something which is black. So, black in the sense, nothing is comes out from this astrophysical object is called the black hole. Just wait. Going to the black hole in the 10+2, the basic physics, you know, it's very well. Escape velocity. So, escape velocity, basically the maximum possible velocity for a planet. When you provide this velocity to any particle, that particle never come back to the that celestial object or planet or a star. So, in the Newtonian gravity, Newtonian theory or classical theory of the gravity, the escape velocity that can be given by this mathematical expression, which is depends on the mass of the body and the radius of the object, right? So when we believe in the completely pure spherical symmetry object, so which radius are, so escape velocity is inversely proportional to the radius and it is directly proportional to the mass, right? So maximum value of this V, suppose V equal to C. So in the classical theory or in the special theory of relativity, nothing is moving faster than the light. So maximum possible value of the escape velocity for a particle on a planet, which is equal to C, right? So this C depends on the mass. So if mass will be constant and the radius will be continuously decreasing, so at certain radius, this value becomes C. So nothing is just leave the surface of the planet. So this is called the escape velocity, and basically from this, the black hole idea is comes out. So as you can see, if velocity is greater than C, right? If V equal to C, you can easily calculate R equal to 2gm upon C square. And what happens if the velocity, that is particular escape velocity, that is the more than the speed of the light. So that is actually the case of the black hole, right? So in the physics, at different time, different scientists just ask theoretically about this issue. So this question first time asked in the 1783 by the John, and Laplace investigate this situation in the classical gravity in 1796. But the concrete and the mathematical theory of the black hole appears in the Einstein general relativity. General relativity, basically the relativistic theory of the gravity and the theoretical physics evolve in the three particular directions: Newtonian gravity, quantum mechanics, and special relativity. And when you combine the special relativity with the Newtonian gravity, then general relativity will comes out. So later we will see, right? So to understand what exactly happens with the continuously extremely compact body, continuously collapsing body, so one has to consider the Einstein theory of relativity and special relativity as well. So that is particularly the black hole, right? So in this picture, as you can see, the four stages of the compact object, and we believe in the completely spherical symmetry. So in the first case, if mass is not very high, radius is not sufficiently small. So if you throw the ball is come back, right, on the surface. And the second case, the little bit is strong gravity. And in the third case, very much gravity. And last, as you can see, when you throw the ball will come back to the surface. So this is the basically idea about the escape velocity, which is equal to root 2 gm upon this r factor. R factor is the radius of the object, and the maximum possible velocity of a particle, which is equal to c. So corresponding to c, it is not very difficult to calculate this r equal to 2 gm upon c square. And this particular radius is called the Schwarzschild radius. Later we will see what is the Schwarzschild. Schwarzschild tried to solve the Einstein field equation for the spherical symmetric body. So this radius is called the Schwarzschild radius. Sometimes this radius is called the event horizon, right? So this is idea of the black hole in the classical gravity or Newtonian physics. And in this situation, as you can see, the black hole is basically the region of the space and time, right? So space and time, not two separate things. Space and time, they are just one together. According to Einstein, they not discriminate. They don't say space and time both are the different, both are the single part. So called the space time, and the space time is called due to the gravity, right? And the curvature in the space time, that is because of the either coordinate transformation, either because of the gravity. And gravity, that is comes from the mass, right? So black hole, basically the astrophysical object or entity from which nothing comes out, even light, right? Even light that cannot leave the surface of the entity is called the black hole, right? So what happens if the mass is just constant and the system continuously just going to collapse, right? You are not changing the mass, you just system will going to continuously collapse. At certain radius, the escape velocity becomes speed of the light, right? So what happens? So all the metal elastic particle which the speed is the less than the light, that cannot leave the surface of the that particular planet, they are continuously collapsing. But when light also not leave the surface, and if the escape velocity more than the speed of the light, then nothing comes out from the surface, and that is the stage of the event horizon, right? So radius, you remember this radius is equal to 2 gm upon c square, where capital G basically the universal gravitational constant, and m is the mass of the object, and c is the speed of the light. And you just plug together mass m and the speed c equal to 3 lakhs kilometer per second, and mass, you can suppose the solar mass. So you will be easily calculate what is the radius up to which the nothing comes out from the sun, and that would be around 3 or 4 kilometers, right? So if our sun start to collapse and attain the radius 3 kilometers, then light cannot leave the surface of the sun, and that is the stage of the event horizon. And somehow the radius will be just less than this particular radius, which is equal to 2 gm upon c square, and then also light is not coming from, and this is stage of the black hole, right? So in nutshell, black hole is the region of the space time from which nothing comes out, including light, right? So Neutron star, the simple baryonic star that is populated by the neutral hydrogen, and in the core of the star, nuclear fusion occurs. So as you can see, the radiation is just leave the surface. But in the case of the neutron star, there will be the different mechanism how the neutron star form. I will just look in the few or 3 or 4 slides. So in this case, as you can see, the second panel of the picture, especially B, the light is little bit bending. As you can see, this is the bending, and this bending of the light because of the gravity, right? In the Newtonian theory, there is no any effect of the gravity on light. But in the Einstein theory of gravitation, that is called the general strong gravity, the space-time will be curved, and due to the curvature, the light will be bended, right? So this bending because of the strong gravity of the neutron star, and as you can see, the light is completely not completely bent, but black hole is the more compact than the neutron star, and the light is just leaving and come back to here, right? Leaving from the surface, so nothing is comes out, right? So it is very difficult technically how to detect this, right? How we know there will be the black hole. So this is the one of the independent questions people struggling to investigate the black hole, how to concept. So there will be the some indirect effect, right? And this black hole just eat the mass nearby stars and nearby the object. So here the light is not coming out from the surface, and this is the form of the exactly black hole. So the Subramanian Chandrasekhar, which mass limit is called the Chandrasekhar limit. Chandrasekhar limit mass. So that will be changed into the simple white drop. But if the mass of the star, which is more than the 3 times of the mass of the sun, or more than 3 times of the mass of the sun, that would be either in the neutron star in the black hole, right? So few basic things how the stars is formed. So black hole is the ultimate stage or last stage. Basically, this is the stage of the death of the star, and not all kind of the star after the death they are just converted into the black hole. They either go into the white dwarf, neutron star, or in the black hole. That is decided by the Chandrasekhar limit, right? Mass of the star. But before going to the death of the star, we should know what is the star, how they are formed. So the recent theory and most successful theory, gravitational collapse, right? So gravitational collapse, that means our interstellar medium that is mostly populated by the neutral hydrogen and helium, they just start to the collapse, and this collapse triggered by the distant supernova explosion or some other kind of the instability, and due to this instability, the interstellar medium or interstellar cloud start collapsing, right? So the fundamental mechanism, this the Jeans instability or gravitational collapse is the basics fundamental mechanism behind the structure formation, right? So in the mathematical calculations, this will be the dimension of the mass is called the Jeans mass, and Jeans mass is the function of the temperature, right? Here m is the mass of the collapsing interstellar medium, rho is the density. So as you can see, this Mj is called the Jeans mass. So if the mass of the cloud is more than the Jeans mass, then collapse will be started, right? So this is the mass criteria, and that is appears in the Jeans instability. So in the gravitational collapse, you remember this one, mass of the cloud or interstellar medium should be more than Jeans mass, then gravitational collapse will be started. This is the fundamental criteria. And second, when the gravitational collapse is started, then there will be the free fall, right? So free fall means after how much time the collapsing body or the mass, they just collapse to the single point. So you can easily calculate simple the dynamics. Free fall time, which is equal to 1 over density rho, right? So it is depends on the density and not depends on the radius, right? So when the mass around the sun are approximately equal to the sun, they start to the collapse. So around the 10 to the power 5 years, molecular cloud, they will be collapsed at the single point. And this type of the collapse is called the isothermal collapse, right? And after the isothermal collapse, there will be something, not the all the interstellar medium just collapse. There will be the patches, is called the fragmentations. And what is the fragmentation? As you can see, R equal to 0, and the cloud just collapse and density just rises, right? When R is decreases, density just rises, mass increases, density will be rises, mj of the cloud is falling. So small pieces of the cloud collapse, right? And the rising density, this means the free fall time, decline the free fall time. When the free fall time is just declined, so small dense clumps of the collapse, they just collapse very quickly, faster than the overall the cloud, right? So one giant cloud undergoing to monolithic collapse, the cloud fragments into the small collapsing. So not the whole body, there is the small patches of the interstellar medium, they just collapsing, right? So these all the things, although there will be the use and massive mathematical calculation of the gravitational collapse, but you just know interstellar medium, the interstellar medium triggered by some distant explosion, and they just start to moving toward due to the local gravity. And somehow if the mass of the collapsing body or mass of the interstellar medium, which is more than the Jeans mass, and Jeans mass is given by this mathematical expression, so this is essential condition for the collapsing body, right? And when they are just collapsed, so the gravitational potential energy that is converted into the form of the energy or radiations. So yeah, another process is called the adiabatic process. So in this sense, when the gravitational collapsing body, the radiation pressures inside the collapsing body try to counter the gravitation pull, gravitation collapse, and somehow the system will be just get the equilibrium. So as I can see, show you in what exactly happens. Yeah, just wait. So screen is visible. This.
Yes, sir, it is
Yeah.
visible.
So look here. This is the random interstellar medium, which is populated by the neutral hydrogens, and somehow instability just start, they are just triggered. So the interstellar medium coming close together, and then, as you know, gravity in the Newtonian dynamics, they have nature to the attractive. So due to the gravity, the system will be try to collapse inside, and in this collapse, the change in potential energy converted into the heat, and the temperature will be rises. Temperature will be just rises, and when this temperature attain the temperature at which the nuclear fusion started, and once the nuclear fusion started, so the radiation pressure, that is because of the radiation or nuclear fusion inside this core, they try to counter this gravitational collapse further, right? So suppose in the perfectly, again, has just got very bad. Yeah, but you understand this is the perfectly spherical symmetrical object. So this arrow inside represent the gravitational collapse, and radiation pressure that is counter this gravitational collapse in outer side, right? Yeah. So change this color. The red vector, that means the radiation pressure or pressure force, they just counter to the gravitational pull. And if this radiation pressure or radiation force exactly equal to the gravitational collapse or gravitational force, the system will be attain the hydrodynamic equilibrium, right? This is called the hydrodynamic equilibrium, and the system is called the virial condition. System is just virialized or attain the equilibrium, and stability will be achieved. And this is the case of the star. But somehow all the hydrogens inside the interstellar medium are in this star just fused together, right? So the radiation force is little bit less than the gravitational collapse or gravitational force, and this gravitational force dominate over the radiation pressure, and its radius will be squeezes, right? The radius will be contracted again and again. Radiation pressure is not sufficient to counter the further the gravitational collapse. The radius will be decreases, right? Radius will be this decreases, and at certain stage this radius r is equal to 2gm over c square, right? This is the particular radius, is called the Schwarzschild radius or radius of the event horizon. And when this is equal to 2gm upon c square, this means the escape velocity ve, which is equal to c, and this is comes out root 2gm over radius rs, right? So when this collapsing body attains this particular radius, and that means light is not coming from the surface of this collapsing body. So this is the one case of the Newtonian black hole, right? And further, if the mass, their mass is play the very crucial role in the gravitational collapse, and if this mass is equal to Chandrasekhar limit, so it is not necessary that will be converted into the black hole, that will be converted into the white dwarf. And white dwarf is basically the stage of the death of the star, which core is populated by the degenerate electron gas. Degenerate electron gas means quantum degeneracy take the very crucial role in the collapsing, and I will discuss in the later how the white dwarf is just formed. So here just you understand the gravitational collapse just countered by the radiation pressure, and in this sense we have the escape velocity which is equal to speed of the light, right? So yeah, now PPT visible. Now it is visible. So similarly, the adiabatic collapse, like the isothermal collapse, and this is derived from the adiabatic process in which the heat transfer is completely zero, dq is equal to 0, and isothermal process, the thermodynamic process, in which the temperature will be constant, right? So yes, the life cycle of the sun like our massive star. So here the nebula is considered as the star factory, where the star is just formed, interstellar medium is just collapsed, and cloud of the interstellar medium, mass of that cloud is more than the Jeans mass, and sun like the star, as you can see here, if the mass of this collapsing body is equal to mass of the sun, then after all the nuclear process inside the core is just finished, then that becomes the red giant, and red giant, then planetary nebula, and then finally the white dwarf, right? And if this protostar, which mass is more than the mass of the sun, and then as you can see here, red supergiant, and red supergiant, after this there will be the explosion, is called the supernova explosions. And supernova explosion, if the mass is very high, then that will be converted into the black hole, either that will be converted into the neutron star. And white dwarf, that is because of the supernova type 1A explosion, and there will be the degeneracy. But in the case of degeneracy of the molecules, so proton just capture the electron, and the remaining part will be neutron, and neutron is populated. So core of the star is populated by the neutron star, that becomes a neutron star, again the compact object. And if the mass is very high, then that will be the black hole. So complete life cycle of the star form in the nebula, here the nebula, then shining, maximum stage, slowly the luminosity will be decreases, red giant, supernova, either white dwarf, neutron star, or black hole. This is the complete life cycle of the sun, or sun like the star or massive star. So in this picture it is very clear. So star nebula, So average star means the star just like our sun here, and then stage is the red giant planetary nebula, and that is converted into the white hole. Not white hole. White hole is the some different concept. Point together with the black hole. Here the white dwarf. So don't confuse with the white dwarf and the white hole. And there will be the wormhole also. So wormhole is the shortcut in the space-time. So that will be discussed later. So if the mass of the star is the same as the sun mass, so the depth in terms of here, white dwarf. But if the mass of the star is very huge, that is more than mass of the sun, that red supergiant, then supernova, and after the supernova, either neutron star, either black hole. This is the simple life cycle of the star for the layman, and detail about what exactly happened after the achieving equilibrium. The star equilibrium means the radiational pressure that is sufficient to counter the further the gravitation collapse. This is called the hydrodynamic equilibrium. And red giant, loss of the fuel in the core, expansion by the 1,000 times, and then explosion. The star has no energy left, begins to lost in layers and form the complex structure. It's called the planetary nebula, and white dwarfs is just born. And second case, if the mass of the star more than the sun mass, and mass of the sun is called the solar mass, that is represented by m dot. So that will be converted into red giant, right? And then supernova, and then either neutron star or black hole. Okay, so the same things, but a little bit more clear. Yeah. So stellar remnants. So stellar remnants are death of the star. It will undergoes the contraction that can be halted only if it reaches a new state of the equilibrium, right? So depending on the mass during its lifetime, the remnants just in the three particular forms, either white dwarf, neutron star, or in the black hole. So if we pack electron close enough together, follow the Pauli exclusion principle. According to Pauli exclusion principle, the fermions, they cannot live together in the parallel spin state, right? They will be always in anti-parallel spin state. But in the case of the bosons, so numbers of the boson, they can live together in the same spin state, right? So the particle classified, there are the huge number of the elementary particles, they are classified on the basis of the spin, either fermions, either bosons. And fermions further classified in the different form, right? So electron, protons, neutrons, they are all the fermions, right? And on the basis of the interactions, the particles either fermions or bosons, hadrons and the baryons, leptons, they are the elementary particles. So if you're interested, then you separately contact me or go through the elementary particle physics, right? So if we pack neutron close enough together, neutron star will be the form. So in the core, electron degeneracy and ion degeneracy. So ion degeneracy consequence neutron star form, electron degeneracy consequently the white dwarf is formed. Gravity is opposed by the electron degeneracy pressure, and electron degeneracy pressure, if you consider just electron as the classical gas, then you will use the Maxwell-Boltzmann, mainly statics. Classical particle follow the Maxwell-Boltzmann statics, and the quantum particles, they follow either Bose-Einstein statics or Fermi-Dirac statics. So since electrons are fermions, they will follow the Fermi-Dirac statics. So use the Fermi-Dirac statics. So the pressure, when we consider the electrons are classical gas, so which pressure is less than if you consider the quantum effect of the electron, so it's called the degeneracy. In particular, in the quantum mechanics, the degeneracy means the multiple energy state will be formed in the single state. It's called the degeneracy. So gravity is opposed by the electron degeneracy pressure, and core dominated by the degenerate electron gas. That is the particular is the white dwarf. And Chandrasekhar limit, which is decide the star is converted into the black hole or neutron star are in the white dwarf. So the maximum, the value of the mass of a stable white dwarf star, that is decided by the Chandrasekhar limit, and which value is comes out 1.39 mass of the sun. Here this symbol is the mass of the sun, or roughly it is 1.4 mass of the sun, right? So the supernova, type 1a supernova, basically in the case of the white dwarf, and type 2b supernova in the case of the neutron star in the black hole, right? So yeah, again, yeah. So few things about the neutron stars. Neutron star nowadays a very hot topic in the astrophysics and cosmology also. They are also considered the pulsars. So neutron star, when the mass of the star is more than Chandrasekhar limit, right? Supernova type 1b, type C, or type 2. And type 2 supernova results from the rapid collapse and violent explosion of the massive star, right? But no more than 40 to 50 times mass of the sun. Okay. So just like the Chandrasekhar limit, another mass limit is called the Tolman-Oppenheimer-Volkoff limit, TOV limits. And this limit is upper bound of the mass of the cloud, non-rotating neutron star. And if this mass of the neutron star just does the certain limit, then collapse will be in the form of the black hole, right? So remember the Chandrasekhar limit as well as Tolman-Oppenheimer-Volkoff limit, right? Both decided the death of the star either in the form of the neutron star or in the form of the black hole, right? So the appearance of the star composed of the exotic matter. Exotic matter means the neutron star also very exotic, and matter, exotic matter, preons or quark are the elementary particles just like the leptons. So in this sense, they are called the exotic matter. So the appearance of the star composed of the exotic matter and their internal layered structure is not very obvious, and proposed by the equation of state of the degenerate matter is highly speculative. So other hypothetical degenerate matter possible: quark star, strange star, that is dominated by the strange quarks. They are the 6th category of the quark, or preon star if they exist, and then in that sense it is not distinguishable from the neutron star. They are all indistinguishable, right? So these all the things. In this sense, neutron star just considered a very hot topic in the astrophysics, right? And the people struggling to identify more physics, more internal structure of the neutron star. And in this picture, as you can see, basically the structure of the neutron star: core here, inner core, massive star, and gravity. Due to the gravity, and the ions just degenerate, and the ion degenerate, neutron will be remains, and finally the neutron star will be formed, right? And the next is the black hole. And black hole basically it started in the Newtonian gravity by the consideration of the escape velocity, but the detailed mathematical theory that will be because of the Einstein theory of relativity, right? And Einstein theory of relativity, special relativity, and the general relativity. And as you know, the general relativity is the relativistic theory of the gravity. Special relativity plus gravity is called the general relativity, right? So Tolman-Oppenheimer-Volkoff limits, and roughly it's 2 times of the mass of the sun. So no known form of the cold matter can provide the force needed to oppose the gravity. So in this mass limit, the radiation pressure inside the core not sufficient to counter the further the gravitational collapse. And in this sense, the perturbations in the dynamical equilibrium and gravity dominate on the radiation pressure, and collapse will be continued, right? And with nothing to stop it. So gravity is so high, and that will be continuous collapse, and singularity will be formed, and that is the formation of the black hole. So according to general relativity, if the compactness is called the compact parameter, mass over the size, m by r is called the compact parameter, and dense parameter, mass over the volume. right? So here the compactness, mass can deform the space-time to the form the black hole. And as you know, the fundamental principle of the general relativity, the mass they just curve the space-time, and curvature decide how the particle is moved inside the space-time, right? So when the mass is very high, then space-time will be curved, and if the curvature is very high, then light will be just trapped in that curvature, trapped in that particular massive object, and that is one case of the black hole. And if it look like the simple, but it's not very simple. Schwarzschild was the first person who solved the general relativistic equation, Einstein-Field equation, by considering the spherical symmetric object, and obtained the first time the concrete mathematical theory of the black hole. It's just so general relativity predict the black hole should be exist, right? So there are the so many kinds of the black hole. Black hole either rotation, non-rotations, charged or uncharged. So different metric. Schwarzschild is the simplest one. No charge, no rotation, static, right? So the photon sphere is the spherical boundary of the zero thickness in which the photons that move in the tangent to the sphere, and that would be the trap in the circular orbit about the black hole. So thanks to the Event Horizon Telescope, and all of you aware with this picture, this is the picture of black hole, right? So recent picture of the black hole, as you can see, and black hole, few features, its property, very strong gravity, black hole having the very strong gravity, and due to this gravity, they have to just suck everything. So object can orbit around the black hole indefinitely without getting any closure. So due to the multiple gravitational force acting, so the things approaching to the black hole, the tidal force is acting, right? So the things will be just stretched out, and they're just going inside the black hole. The second technical term, event horizon. So event horizon means, as you remember, the radius we obtain, which is equal to 2gm upon c square. So this radius is called the event horizon, or the size of the object with the radius r is equal to 2gm upon c square is called the event horizon. And Stephen Hawking, he just calculated the event horizon of a non-spinning black hole is a sphere, right? He just calculated that will be follow the spherical topology. And the event horizon, the escape velocity is more than the speed of the light. So that's why nothing is comes out. And external observer cannot probe the inside the black hole. They nothing know, because the nothing is comes out from the black hole. So that's why the observer who seated outside, they cannot detect it. So no hair theorem proposed by the Stephen Hawking. So the three parameters, mass, angular momentum, and electric charge, these 3 degrees of freedom to analyze the black hole, right? So Wheeler, John Wheeler, black hole have no hair, right? This is called the no hair theorem, famous no hair theorems. That means no feature that distinguishes one black hole from the another black hole apart from the 3 degrees of freedom, mass, charge, and angular momentum. So mass, charge, and angular momentum, only the 3 parameters that distinguish the 2 black holes. It's called the no hair theorem. Next is the singularity. So as you can think, if the collapse is not stopped, because the agent who tried to stop the collapse, that's just killed. So nothing is remains. Radiation pressure is not sufficient to counter the gravitational collapse. So what is the ultimate fate? Yes, all the mass will be collapsed at the single point, which radius is equal to 0, right? When the radius is equal to 0, so gravitational force that becomes very huge, infinite, and it is not very good for any theory. Theory should be free of the singularity, and at that singularity you cannot define the physics, you cannot say anything. So all the law of the physics just violated at this singularity. So singularity will be formed in the case of the black hole, and is the place where the curvature of the space-time becomes infinite. If the curvature becomes infinite, then it's very difficult to propose the physics or what is exactly happens at the point of singularity. and it is very dangerous things, right? So many things, either singularity is the essential singularity or artificial singularity. So artificial singularity, by using the coordinate transformation, you can remove the artificial singularity. And essential singularity, you cannot remove the singularity in your theory by the putting the coordinate transformation. That will be essential inherent property of the space-time, right? And it is not good. But bouncing model, in the bouncing model, no singularity. I just recently published the paper, bouncing model, that is available online. If you're interested in the singularity, then you can go through. So most of the theorists interpreted the mathematical singularity of the equations, indicating the current theory is not complete, and the new phenomenon must play the one approach to the singularity. So physics in our hand, that is not complete, no? That is incomplete. They try to not explain exactly what happens inside the black hole, what exactly physics at the singularity. This is our incapability, and we are struggling to propose the complete physics that try to explain the things inside the singularity. The next is rotating black hole, right? So black hole having the some angular momentum. If the black hole carries the angular momentum is because of the rotations. If rotation speed equal to 0, then angular momentum will be 0, and angular momentum should be conserved. And this is conserved because of the symmetry. It's called the space-time continuous symmetry. And isotropic symmetry means rotational symmetry leads to the conservation of angular momentum, and the translational symmetry of the space-time leads to the conservation of linear momentum. And similarly, the time leads to the conservation of energy. And it is not very difficult. You just handle the Euler-Lagrangian equation, putting this symmetry, three symmetry, then you will have these three fundamental conservation laws. So ergospheres will be the form because of the rotation of the black hole. And the next property, entropy and the Hawking radiations. And you heard several places what is the Hawking radiations. So Hawking first time encountered this one. There will be the quantum fluctuations near the black hole, and according to quantum field theory, there will be the quantum fluctuations inside the black hole, and the particle anti-particle will be created, and the particle just going inside the black hole and anti-particle just comes outside. So by the detecting those anti-particle, we can say anything about the black hole, and this is called the Hawking radiations. And he just proposed the entropy, and this is called the Hawking-Buchenstein theorem. So entropy, that should be proportional to surface area of the black hole, right? And entropy is because of the gravitational entropy and the geometrical entropy. Mansi, I am just trying to conclude very quickly. So next, black hole unitarity theorem, sometimes is called the information loss paradox. Information loss paradox means, what about the information? Because nothing is comes out from the black hole. So what about the information? Information that should be conserved, probability should be conserved. So when you combine the quantum theory with the general relativity, so in this sense, the quantum information loss paradox or black hole unitarity paradox, this is now alive, and people are just struggling, and the principle of holography is comes out. Leonard Susskind is the leading worker. He is working in this area. And as you can see, singularity here, this line is the singularity, and the red color is horizon, right? This is the horizon, which radius is equal to 2gm upon c square. And due to the strong gravity, the light cone will be tilted here. At this surface, when you approaching to this radius of the event horizon, your light cone will be just tilted. And we, all of us, communicate to each other because of our word line intersect to here. I am speaking here, your word line and my word line, they are just intersect at the simultaneously at particular time, then you communicate with us. But somehow, if I just send the signal and your word line intersect my word line in the near future, then you will be causally connected with us. And that is because of the light cone not tilted. But due to the strong gravity at this surface, as you can see here, this blue color line here, when it is just distortion of the this light cone, and nothing is comes out, right? You cannot define. And this is area is the singularity, and what happens is here. So this is very good picture about the black hole formation and few mathematical theory, how the black hole is appears in the mathematical theory. When you handle the Einstein field equation, here the Einstein field equation with the cosmological constant term lambda GIK, and the right hand side is the matter part. This matter part is the basically the energy momentum tensor which decide this curvature. So RIK, existence of the RIK because of the TIK, right? TIK is the energy momentum tensor. They just create the curvature, and this curvature RIK decide how the particle is just moved, right? So you just think about why our Earth moving elliptical orbit around the sun, because sun create those paths. So the elliptical orbit because of the sun gravity, and that gravity provide this path, and on this path the particle is just moved. This is a beautiful idea about the Einstein field equations. So when lambda is 0, no cosmological constant, Schwarzschild just solve analytically this equation for the metric, and the solution is here, obtain the Schwarzschild radius, right? So for example, if you consider our Earth start to collapse, no radiation pressure, then what happens? If our Earth mass is just constant and radius is equal to 9 millimeter, around the size of the simple marble ball, so that becomes the black hole. Anybody that become the black hole, that should be continuously collapse, and the radius attain this particular value, RS equal to 2 upon C square. When you just plug the mass of any mass of the body, when M is equal to mass of the Earth, then RS is equal to 9 millimeter. Similarly, the sun is equal to 3 to 4 kilometer. So that will be anybody that converted to the black hole according to this theory. But there will be some different physics. They try to collapse Chandrasekhar limit, so blah 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 like this. So many the counter, but ideally the things will be happens like this, right? And the Schwarzschild radius, as you can see, the density of the black hole, which is the function of the mass, right? Here it is completely depend on the mass, and from this mathematical calculation you can obtain. So here in this table you can see the parameters. If the black hole is uncharged, no rotations, no angular momentum, is called the Schwarzschild black hole. Simple. And if you consider the rotations, then Kerr metric will be involved, and you just solve the Einstein field equation for the Kerr metric, then you will obtain the rotating black hole. And now the another consider the charge. The black hole is just charged, but no rotations. So regional Nordstrom matrix, solve the Einstein field equation, then you have the dynamical feature, some mathematical expressions, and Kerr-Newman matrix, in which you consider the black hole is charged as well as rotations. So these are the four metric, and how to solve this Einstein field equation. You define the metric, plug the metric, there will be the GIK, and then you obtain the gamma Christoffel symbols. Then RIKLM, Riemannian tensor, Ricci tensor. RIK is the Ricci tensor first term, and R is the Ricci curvature. GIK is the metric tensors, and simple you solve, then you have to obtain the relation. In my student Devanarayana, and in our group we published the paper, the solution of this Einstein field equation for the black hole, that appears in the JHAP. If you're interested, then go through, and now it is available free of cost, right, in 2022, right? So after this, the several alternative approach of the black hole. As I told you, singularity is not good for the any theory. So so many approach. In the George Chaplin Lawrence Laboratory, California, they just say the prions, the black hole is a fulfill of the dark energy, right? And dark energy try to stop the collapse, matter collapse, because they have the repulsive gravity. Due to the influence of the dark energy, our universe is the expanding or the accelerated expanding. So black hole is just completely fulfill the dark energy, and they further stop to the collapse, and the singularity will be never achieved, right? And wormhole is I just want to share with you. Wormhole is the solution of the field equation like the black hole. So this is the 2 points of the space time, and such a tunnel would provide the shortcut between its endpoints. So yes, wormhole is true. Theory is allowed to the wormhole, that is appeared in the science fiction movie, and I'm just conclude it. So the story never ends nor begins. So don't stop thinking, keep thinking, and see you soon in the classroom. And in our university, astrophysics in the BSc level, and in this year we start the specialization in the master's course, astrophysics, cosmology, and the general relativity, right? we have the very good students. They are all are settled in the Germany, Poland. One student, Akash Kundi, work in the quantum entanglement. He worked with me. And the previous Ayush, he is working in the Germany in the astrophysics. In this year, 2 students they joining the Germany student University of Heidelberg and the University of Bonn. They started to work in the gravitation collapse, right? So thank you so much. I'm very happy to answer the questions. So please, any questions?
Sir, thank you so much. Firstly, for giving this, value for all the students as to what they should need, what they should learn from, the concept that we were trying to say. And thank you so much for crediting your time for our students and participants as well. And sir, we have like few questions. So with your permission, can I take them up?
Yeah, please.
Sir, there is this one question from Radha, and she wants to know how long does it take to make a black hole?
Yeah, it's decided by the mass of the star. So you just calculate the average life of the star, and that is calculated from the free fall, right? Right. So after the average life, the star continues to start the decaying and no further luminosity, and there is the different stages, right? So it's taken too much time. So lakh years, 1 lakh years is a very small time in the astrophysics. It's a very huge time, and that is decided by the after all the mass of the star. Yeah.
Okay, sir. Thank you so much for resolving this query, sir. We have another query, and this query read like, can life be possible in black hole?
No, no, life is not possible in the black hole. Black hole is the very strange things because nothing is comes out from the surface. Gravity is too strong, right? So when we just enter in the black hole, then nothing is possible.
Okay.
All the things is merged inside. So we don't have, in fact, personally, I believe we don't have the complete physics that will be tried to handle what happens exactly inside the black hole. Although the Hawking tried to explain by the Hawking radiations, right? But the Hawking radiation is not sufficient to give the information. Yeah, please, next.
Yeah, sir, there is last, but of course not the least query.
Yeah,
are there any white holes along with the black holes?
Yeah, white hole is just a symmetry of the black hole. In the black hole, there will be the merging of the mass, right? So white hole that exists in our universe, from where the things will be just going to the free. Black hole, the things merge. White hole, the thing is just coming out. Yeah. So in the theory, we can calculate the white hole, but it is a pure hypothetical, right? But the wormhole is okay. When you solve the Einstein field equation, then you can mathematically obtain the wormhole.
Yes. Sir, thank you so much for resolving the queries, and I hope all the attendees and participants must have got their queries resolved. And if you can post it other queries as well. Meanwhile, we will be taking up the admission queries. Sir, before that, I would just say thank you so much for joining in, and thank you so much for giving them this valuable information. And I would urge to all the students to start learning about this very interesting topic and start researching. As sir has told, there can be multiple research that we can do. So I would ask you to please start coming in the university and start studying the topics and start doing the research in different countries and of high repute and universities of high repute. Sir, with this, okay, there's just one question. How do scientists calculate the mass of a supermassive black hole? From Sapna Sagar.
Mass we cannot calculate because the black hole, the nearby object, they just going inside. So when the mass is inside going inside the black hole, the radius will be increases, and that radius will be basically the event horizon, right? So in that sense, by calculating the entropy, by calculating the radius, you can estimate the mass of the black hole, but that's not exact figure.
Okay, I hope Swapna, you must have got the answer that you were worried for. So now, sir, I would take your permission to take some admission queries and to show them like how they can take the admission in here and the little process, how they can approach us and how they can take part in the favorite course. So can I do that, sir?
Yeah, please.
Okay. So for all the students, who just want to know like when you can come in, from where you need to apply, and what all the process is going to be. For this, I will be just sharing my screen in a bit, just in a moment. Yeah. Okay, so I'm sharing my screen in here. You can see my screen. I hope my screen is visible to all of the students now. Yeah. Okay. So students, what you need to do is, we have very simple process for you to be able to come in here, and that is just go on this site. This is lpu.in. That's it. Just click on this and you will be seeing this interface here. You can see all the happenings that has happened, either are happening, or maybe in future they will be happening related to the university, are all posted on the front side of website. Now, since we're catering about admissions, right? So simply click on the admission and you can see all the segregated programs in here, after 12th, after graduation, after 10th, postgraduates, doctoral diplomas, etc. Now, we will be taking maybe an example. Okay, for example, you have done your 12th and you want to take admission in here. So what you need to do is, you want to go to this undergraduate program and simply click on regular programs. When you click on regular programs, there will be a whole lot of disciplines that would be visible to you. As you can see here, you can see engineering, management, commerce, economics, fine arts, Punjabi, geography, all the disciplines that are visible to you. Since we were talking a lot about the science and physical sciences and the physics, so why not go with the physics discipline? So once we click on the physics discipline, we can see all the programs that are offered under that particular discipline. So for example, here we can see that we have BSc honors physics. Okay, so we just want to know the details about the course. We simply click on that. So once we click on that, you can see a whole lot of details in here. So these are the options which we will be briefing in a moment now. Okay, so first thing first is, this course will be of 3 years. That is going to be 6 semesters for you, right? So here you can find the duration of the course, and then we will be finding eligibility. Where you need to go to find the eligibility is on program details. So you can find the eligibility, and this is here. You need to have at least 60% marks in your 10+2, with English, physics, and maths should have been your subjects in your 12th grade or equivalent, and you also have to have either LPU NEST test being qualified or CUET test. Okay, so I will be in a moment telling you how you can apply for this LPU NEST test if you have not applied for CUET, right? And once we go down, we have our highlights option in here. You can see there's highlights option, that we have all the research publications, what all students have achieved, all are listed here. Now, the most important thing for any student when they come in the university is the ranking of the university related to the course. And you can see that all the rankings that are listed here. Right now, this is something very interesting to find out for any student to make a very disciplined decision, and that is the curriculum. In LPU, we provide first-hand curriculum. Like before you even enter in the college, you know what you will be taught and what all subjects there are gonna be. You simply click on the subjects, you will be getting out all the details of the subject. You can see this is autumn term, spring term, first year, second year, and third year. So you can just check it out. You just want to check what all topics you will be studying, and after that make a disciplined decision whether you want to pursue in that course or not, right? Now the very important part, that is the fee structure for any course, is you can simply click on this fee, or either just scroll a bit, and there you will be finding all the fee in here. You can see our program fee is 50,000 per semester, right? But again, this is not the usual fee that our students pay, because they get a lot of scholarships, and scholarships are based on different categories. And you can see in here we have category 1, 2, and 3 of our scholarships. So on what basis you can get scholarship? So either you will be getting scholarship on your 12th aggregate marks, right? So for example, here you can see if you have scored 95% or above in your 12th grade, you're directly eligible for 28% of the program fee. That is around 14,000 rupees will be less in your per semester fee. Or if you have scored good marks in your LPU NEST test, right? The test we were just talking above. So what is that score that you need to aim for the for you to be able to get this scholarship. You can simply click on this category 1 cutoff, and there are the tentative cutoffs you can see. Your question paper will be of 400 marks, and at least you need to have 330 or above marks to be able to get category 1 cutoff or category 1 scholarship, and hence you'll be getting 28% of the program fee. Same you will be getting for category 2 25% and category 3 20%. You can simply check it here from the website. Now, for example, you were not able to get any of the scholarship, sadly, but do not be sad, we have other scholarships as well. You can see we have scholarships based on innovation, startup, entrepreneur, sports, culture. So you need to check it out, in which scholarship do you fall in, and simply click on that and start applying for the scholarship. Now there is a very much important thing, is important date. What is that date before which you can take? And it is the 31st May 2023. It's just 14 days from now. Start applying for the course, start applying for the test, and after that you will be able to get your admission. Now date of examination is only 8th May to 31st May, right? But last date of admission is 15th May 2023, and if I'm not wrong, this is today only. So just start apply for the admission, and how you can apply is from here. You can simply click on this apply now option. There are bare minimum requirements that will be asked from you. You can see name, gender, address, etc. And after that, once you submit, you will be given a dashboard of yours, and from there you can simply apply. Now I hope I have resolved all the queries as to how you can take admission. If you still have any other queries as well, you can simply just either call us right from on the site only, either WhatsApp us, or have a live video counseling session as well, right? Last but not the least, once you scroll down the site at the end, these are the numbers of our esteemed counselors. You can simply call on them, you can write it down, you can take a screenshot of it, and after that you simply call us, and we will be here to provide our assistance to resolve your queries. So I hope I have given all the details as to how you can take part. And for more queries, you simply need to either call us or WhatsApp us, and we will be here to provide our assistance. And sir, with this, I take your permission to wrap this webinar up. If you do not want to add anything, sir.
Okay, thank you.
Okay. So thank you so much, sir, for joining in, and thank you so much for giving your time, your knowledge to us, and thank you so much for our audiences as well for being so much patient with us and for being very much interactive with us. And I hope that sir has resolved all your queries. And for more queries related to the admission process, you need to just visit our site, that is lpu.in, and there you will be finding all our numbers, and start applying for the course and start studying. So until next time, I'll meet you soon in the next webinar. And until next time, stay safe and stay healthy. And thank you so much for joining in.